This seventh set of lecture videos is going to cover topics relating to rotational motion. The goals for this chapter are find angular displacement, find angular velocity, find linear velocity of a point on a rotating object, analyze problems involving angular acceleration, apply the torque equation to rotational problems, find centripetal force, find power in rotational systems, and analyze how gears, gear trains, and pulleys are used to transfer rotational motion. The first topic we are going to take a look at is rotational motion in general. Rotational motion occurs anytime an object itself is spinning. Some examples of rotational motion are the Earth spinning on its axis, wheels or a drive shaft on a car spinning, or a CD or DVD spinning. When we are talking about rotational motion, we need to be able to explain how much rotation we have. There are three different ways that we can measure angles. The first way we can measure angles is the revolutions. One revolution is one complete rotation of an object. Revolutions are just measured in revolutions, abbreviated REV. The second system we can measure angles with is the degree, which you are probably already familiar with. 1 degree is 1/360th of a complete revolution or rotation. We will need the conversion factor that 1 revolution is equal to 360 degrees later on. The last way to measure angles is in radians. A radian is an angle with its vertex at the center of the circle whose sides cut off an arc on the side of the circle that is equal to its radius. 1 radian is equal to 360 degrees divided by 2 times pi, or we can say that theta equals s divided by r, where theta is the angle measured in radians, s is the length of the arc of the circle, and r is the radius of the circle. Radians are a dimensionless unit, and we can see this in the equation for the angle. If we take a length divided by a length, the units cancel and we are left with no unit. So technically, radians don't have a unit, and we can't use the term radian to mean a unit. Here are a few useful conversions between the three systems of measuring angles. 1 revolution equals 360 degrees, which is equal to 2 pi radians. You will need to convert units in the homework, so make sure that you know these conversions. It is also important to note that these are considered exact numbers, not measurements, so these values will not count towards your significant digits. Let's take a look at an example where we need to convert between the three systems of angle measurement. Convert 8.50 revolutions to degrees and radians. First, we will convert this to degrees. We will start off by writing 8.50 revolutions. We need to multiply that by the conversion factor that 360 degrees is equal to 1 revolution, with revolutions being in the denominator and degrees being in the numerator. Revolutions over revolutions will cancel each other off and leave us with an answer of 3060 degrees. Next, we will convert 8.50 revolutions to radians. We will multiply 8.50 revolutions by the conversion factor that 2 pi radians is equal to 1 revolution. This tells us that 8.50 revolutions is equal to 17 pi radians, or if we take 17 times pi, we get about 53.4 radians. This concludes our first discussion on rotational motion and angle measurement.